A brand new interstellar object has just been spotted racing into our solar system. And it's moving faster, stranger, and perhaps older than anything we've ever seen. Astronomers are calling it 3I Atlas, and from the moment of discovery, it has sparked awe, excitement, and more than a little mystery. Is this simply another comet from deep space, or could it be something far more unusual? Keep watching because the story of Atlas only gets stranger the deeper we go. On July 1, 2025, the Atlas Survey Telescope in Chile first detected the E object as it hurtled inward from the outer solar system. Even then, it was already more than 4 astronomical units away, farther than Jupiter, yet moving so fast that astronomers immediately knew it wasn't bound to the Sun. Its path revealed a hyperbolic trajectory with an eccentricity over 6.1, dwarfing both Oumuamua and Borisov. Its speed, more than 130,000 miles per hour, making it the fastest interstellar object ever detected. Almost instantly, observatories across the globe mobilized. The Hubble Space Telescope, alongside ground-based giants like the Vera C. Rubin Observatory, began capturing detailed imagery. By July 21st, Hubble revealed Atlas as a fuzzy coma with a teardrop-shaped dust envelope, a clear sign of cometary activity. At first, its nucleus was estimated to be nearly 20 kilometers across, though later refinements put it closer to 10 kilometers, still significantly larger than Oumuamua and comparable in scale to Borisov. What shocked astronomers most was its behavior. Even far from the Sun, Atlas was already releasing gas and dust. Water vapor and oxygen emissions were detected when it was still 3.5 astronomical units away, much earlier than most comets ever become active. This hinted at a volatile, rich composition, possibly tied to its origin in the thick disk of the Milky Way, where water-rich bodies are thought to form. Tracing its motion, astronomers calculated that Atlas was moving away from the galactic center and upward through the galactic plane, a hallmark of thick disk objects. Its age estimates came back staggering, between 7 and 14 billion years old, potentially older than the solar system itself. If true, this would make it not only the fastest and most eccentric interstellar object ever seen, but also among the oldest. Naturally, public fascination exploded. Some scientists, including Harvard astrophysicist Avi Loeb, raised the provocative idea that Atlas might not be natural at all. Its unusually bright appearance, its early lack of typical cometary chemicals, and its near-perfect orbital alignment with the solar system's ecliptic all raised eyebrows. Could it be an interstellar probe, a piece of extraterrestrial technology? The suggestion made headlines, though most researchers urged caution, noting that its water outgassing and comet-like behavior matched natural origins. Still, whether natural or artificial, one thing was clear. Atlas posed no threat. Its closest approach to Earth would be a safe 1.8 astronomical units, farther than Mars. Around late October 2025, it will reach perihelion, its closest point to the Sun, before disappearing back into interstellar space. That short window offers astronomers a rare chance to study a cosmic messenger passing through our neighborhood. And study it they have. Photometric tracking revealed Atlas spins once every 16 hours, with subtle brightness variations hinting at uneven surface features. Its coloration shifted toward red over time, suggesting irradiated organics or freshly exposed dust. Water was confirmed again by ultraviolet instruments, showing production rates that implied vast active surface areas, unusually high compared to typical solar system comets. Some theories suggest icy grains in its coma are driving this early activity, while others propose a crust of irradiated organics covering its surface until deeper layers began to heat. Its retrograde orbit, nearly aligned with the ecliptic, deepens the intrigue. To some, this is just gravitational coincidence. To others, like Loeb, the precision is suspicious, maybe even deliberate. Yet most astronomers remain grounded. Atlas looks like an ancient comet, not a spaceship. Still, its size estimates have been revised down to just 3 to 6 kilometers, reminding us how much about it remains uncertain. By late summer, Atlas was faintly visible to astrophotographers, glowing at magnitude 14 to 16. As it brightens toward October, it will slip into solar conjunction, briefly lost in the sun's glare before re-emerging later in the year. Along the way, it will pass near Mars in early October and near Jupiter by March 2026, offering multiple opportunities for spacecraft and telescopes to capture new data. Every observation reveals something new: a dust mass loss rate measured in tens of kilograms per second, water production exceeding 40 kilograms per second, and colors resembling the reddest D-type asteroids of the outer solar system. These findings challenge models of cometary physics, sublimation, and interstellar survival. Atlas isn't just another comet, it's a time capsule carrying signatures of chemistry from the Milky Way's earliest days. And yet, the mystery lingers. Why did it activate so early? Why is its trajectory so neatly aligned? Is its brightness signaling outbursts or even fragmentation waiting to happen? Each of these questions keeps astronomers staring, measuring, and waiting for the next twist. Atlas reminds us that our solar system is not isolated. From the depths of interstellar space, fragments of alien star systems sometimes find their way here, carrying with them secrets of other worlds. Just 8 years ago, Oumuamua challenged everything we thought we knew. 4 years later, Borisov showed us a comet that felt both familiar and foreign. And now, Atlas takes the stage, larger, faster, older, and stranger than any before. It speeds toward perihelion, the world's most powerful instruments. Hubble, James Webb, the Rubin Observatory, Mars orbiters, and more are all watching. Every spectrum, every image, every flicker of light helps peel back another layer of mystery. Whether Atlas is just a natural wanderer or something more, its fleeting visit gives humanity one of the best opportunities yet to study an interstellar traveler up close, because in the end this story isn't just about a comet. It's about our place in the galaxy. A fragment older than the sun itself, forged in distant cosmic times, now drifts through our skies. Its journey reminds us that we are part of something vast, ancient, and ongoing. A galaxy where stars are born, planets are scattered, and sometimes across billions of years visitors come knocking. And Atlas is knocking right now. Keep watching, because this story is still unfolding. So what have we seen? In just a few weeks since its discovery, 3C Atlas has already rewritten expectations. It's faster than any interstellar visitor we've tracked, more eccentric in its orbit, unusually active far from the sun, and potentially older than the solar system itself. Some astronomers see only a volatile-rich comet. Others wonder if its strange alignment and brightness might hint at something we've never encountered before. Either way, its brief passage offers a once-in-a-generation chance to study the physics, chemistry, and history of objects born around other stars. And this is just the beginning. As Atlas swings toward perihelion, we'll see its activity peak, its tail stretch, and its mysteries deepen. Hubble, James Webb, Rubin, and even Mars orbiters will be watching, and so will we. Every new observation could answer one question, while raising 2 more. Will it fragment? Will it flare? Will it quietly fade back into the dark, leaving us only with data and speculation? That's why if you've stayed with us this far, now's the perfect time to subscribe and join this journey, because this isn't just one story, it's part of a larger, unfolding chapter. Oumuamua challenged our ideas of what an interstellar object could be. Borisov showed us a comet rich in familiar ingredients, and now Atlas pushes the boundary further still. Each discovery adds to a growing puzzle of how other star systems live, evolve, and send fragments wandering into our skies. By subscribing, you'll be here not only for the next update on Atlas, but for the next visitor, and the next after that. Astronomers expect dozens more in the coming years as our surveys grow sharper. Some will be tiny, some spectacular, and who knows, one might even change everything we thought we knew about our place in the galaxy.